we're going to talk about beer. Beer is basically 4 to 6% alcohol by volume. That's ABV, alcohol by volume. We get this from a fermentation of starch that normally occurs from malted grain. There is material that is added as a flavoring, such as hops. Beer production dates back to 9,500 before Christian era. We're looking at almost 12,000 years ago. The process is a rather simple process. We're going to start out with starch. We're going to get what we call a wort, which is a liquid material that is going to be fermented. We're going to get the beer. We're going to look at the process. We're going to start out with malting the grain. When you malt the grain, you start the germination process. Then you stop the process and you dry the grain down. The grain can be powdered. This speeds or hastens the change of the starch into smaller units, which will allow for faster fermentation. Start out by drying the grain down to 14% moisture. Remember, plant material is normally about 70% moisture. This allows you to store it to overcome seed dormancy. Sometimes seed dormancy is a time factor. Then you add water to start the germination process. Normally, you're looking at 2 to 3 days. You can either change the water or you can leave the water. You're trying to get it to pull the moisture back up and start the germination process. When moisture is at 46%, the material is moved into a malting area. It's turned over for up to 5 days to speed drying. What the malting area does is start the process of germination. Then you turn it over and you dry it back down. Now what's happened is you've changed the starches into sugars, be they simple sugars or more complex sugars. You get a material that looks like this. You can see the small radical and the small stalk coming out. This material is then proper for the next process. We kiln dry it to get to a desired color. The more you dry it, the more intense the color will get. The more intense color, that's going into your beer when you're fermenting it. It becomes diastatic. Diastatic means that you have changed the starches into sugar. The malted grain is ground into coarse particles. We call these coarse particles grist. In the past, they used to have what they would call grist mills. Grist mills, rather than making flour, would make larger particles of material that could still be consumed. The process of mashing is where we add hot water to the malt. We take this material that now has a high concentration of sugars in it. It's been broken up into pieces. We add hot water to it, and this allows enzymes that are present to break down the starch that's present in the grains into sugars. Typically, the one we're looking at is maltose. Maltose is a polymerized form of glucose. It also creates a liquid that is called wort. The wort is going to have soluble materials in it. It's going to have coloration that comes from the material that has been kiln dried. It's going to have soluble sugars in it. It becomes a very unique tea-like color that has the proper amount of things to produce the beer. This is a mashing tun, which is basically a large recipient where this breakdown can occur. It's done in temperature stages. What happens is they change the temperature, and by changing the temperature, you get different enzymes working on different things. You start out at 40 to 45 degrees Celsius, you're going to have a beta-glucanase that is going to break down beta-glucan. At 50 to 54 degrees Celsius, you're looking at a protease, which is going to break down protein. Beta-amylase functions at between 62 and 67 degrees Celsius, and then at 71 to 72 degrees Celsius, you have alpha-amylase that's going to break down the starch. We then can have the material that we call beer. Remember, we still haven't gone into the production of the alcohol with the use of the yeast. You raise the temperature up to 78 degrees Celsius. This is done for what they call a mash out, which is where they finish the material off at 71 degrees. It basically cooks these enzymes, so these enzymes are no longer functional. It's now going to allow the yeast to act upon the material and cause the formation of beer. Here we've got a picture of water being added to the barley malt. You can see a lot of it is already germinated, and this is going to give us the kind of wort that we need in order to be able to make beer. The wort is the liquid extracted from the mashing process. Wort can be used to make beer. It can be used to make whiskey. It contains the sugars that are going to be fermented. Wort becomes very important. They drain it off. This looks nothing more than tea. It's got color in it, it's got sugars in it. It is ready then for the next step in the processing. We have what we call lautering, which is a separation of the liquid from the solid residue. We want the liquid part and not the solid residue. The solid residue can be dried down, it can be used for animal feed, it can be used for a lot of things. We're looking at getting the liquid that can be then used for the production of beer. It's done in a lautering tun, which is going to be the recipient where you're going to do the separation at. Afterwards, it is boiled to sterilize the material. At this point, they often put in the hops. The hops is going to give a bitter taste to it. The extraction during the sterilization is going to extract the bitter from the hops. There are adjunct grains that can be put in. An adjunct grain is something other than the barley that we malt. You can use corn, you can use wheat, oats, rice. It's going to allow for increased levels of sugars. They boil the material to solubilize the starch, gelatinizes them as starch. This material can then be put into the wort. It's going to jack up the starch content so that we can get a higher quality material. Fermentation process. We've got top fermenting Saccharomyces cerevisiae. This material, the Saccharomyces cerevisiae, in the top fermentation is used to create pale ale. There's a lot of pale ales around. It's Rolling Rock, it's extra pale, and therefore it is fermented with Saccharomyces cerevisiae. It's doing it up on top. Here's a handcrafted pale ale from Sierra Nevada. It's done in Chico, California. It is a pale ale. We also have bottom fermenting Saccharomyces pastoriensis, which creates what we call lager. Lager is brewed at 7 to 12 degrees Celsius, 45 to 54 degrees Fahrenheit. This is a cool temperature. This is often what they call cold brewed beer, and this is a premium lager. It dates back to 1366. This particular beer has been around for quite some time. We have Brettanomyces, which ferments lambics. Lambics are often with fruit. The sources of the yeast are natural. We know that there are strains of Saccharomyces cerevisiae or pastoriensis that are used. These are more of a natural sort that are often found in caves. They use these natural ones in order to be able to produce these lambics. Here's a picture of a raspberry flavored malt beverage that is called a lambic. We have Torulaspora delbrueckii, which ferments Bavarian Weissbier. This is a whiter type of beer. It's often done with things like wheat. You get a different type of product because of the different type of yeast that's involved in it. Here's a picture of a Weissbier. This particular one was consumed in a German area of South America. This one is made with wheat. You can see the foam up on top of it, the head up on top of it, which really is quite stable compared to some of the other types of foam you get. This is going to be a Weissbier due to the material, the Torulaspora delbrueckii, which is used to make this particular material.